Okay, I just want to talk about the tan graph quickly because the tan graph is slightly different to the other usual graphs that we look at. We know that in general we can look at these different features of a trigonometric graph. The amplitude, the period, vertical shifts, and also phase shifts, right? The issue with tan though is that if you think about it, I've got my tan graph here. What is its amplitude? Right, remember the amplitude is the distance from that center line which the graph reaches, and the maximum distance. The issue with tan is that it actually goes off to infinity, and also negative infinity. So the tan graph, it doesn't really have an amplitude. So it's undefined or has no amplitude, right? So that's kind of out of the picture when we look at tan. The other thing we have to be careful of is when we're looking at the period. We know that the period is the distance required so that the graph is actually repeating. If I come to my tan graph over here, can you see which part of the graph is actually repeating? If I maybe mark these lines here, you've got pi on 2 here. That's your asymptote. And here is another one, 3 pi on 2. Okay, and this is 2 pi over here. Now, unlike the other trig graphs, it doesn't actually repeat every distance of 2 pi. If you look really carefully, you can see I've got this part of the graph here. I'm going to draw a little circle there. Can you see that it actually repeats after that value? Right? I'll use a different color, use black. Okay. Even though you're used to seeing it drawn from 0 to 2 pi, it actually repeats every value of pi. Your graph actually repeats. Imagine just like copy pasting. Boom, this part. Boom, there. I can draw it out again. Use blue this time. Just like that. Okay. And you've almost got like a hyperbolic kind of shape there, right? That's the distance that's required so that my normal tan graph, y equals to tan of x, repeats. So what's its period? Its period is just pi. What does that mean for the general form? Well, it means that if I want to find the period for any general form of tan of x, I use that same idea with b as the coefficient of whatever x is. But I have to change that slightly. The period in the general form is actually going to be pi on b, okay, not 2 pi on b, like the other two functions. So if I come to this function over here, right, same idea, there's not going to be any amplitude, there's no vertical shifts involved here. But what I want to realize is that now when I want to find the period, that's actually going to be equal to pi on 2. Okay? So how often would I expect to see this graph repeating now? Well, if I am sketching from 0 to 2 pi and it repeats every pi on 2, every distance of pi on 2, then I expect to see it repeat 4 times, right? Because 4 times pi on 2 would give me 2 pi. So again, before even just marking anything, I just want to sketch it in. I want to draw my graph of tan 4 times. Now, when I mean the graph of tan, I want to draw the part that's actually repeating. So that's the one that looks vaguely like a hyperbolic kind of shape. And don't forget your asymptotes here. So I might just draw that a bit smaller so I've got some room. Just like that. That's 1, 2. So to draw my third one. And 4. Okay. So just to clarify, right? I've got my first instance, that happens at pi on 2. Then I've got my second instance, that happens at pi. I've got my third instance there, that's 3 pi on 2. And my last instance, that happens at 2 pi. Okay? So that's how I can go about and systematically draw this out. I draw the graph first, and then I put the markings in later. So I'm not trying to squeeze my graph into a really tight spot. Let's look at something like this now. We can actually still have vertical shifts when I look at my tan graph. How's that going to affect it though? Well, it's just going to affect where your graph actually starts, the kind of center axis, right? In this case, I've got a vertical shift of 3, so I just want to keep that in mind. What's happening with the period though? Well, remember, the period is equal to pi divided by the coefficient of x. In this case, it's just half. So pi divided by half, well, that's just going to be 2 pi, right, if you take the reciprocal. So what does that mean? I expect the graph to repeat at a distance of 2 pi. And it just turns out I'm sketching my graph from 0 to 2 pi. So I expect to see this shape just happen once. I want to account for my vertical shift too, right? So I'm not starting at 0 anymore, we're starting at 3. Okay. So I'm going from 0 to 2 pi. And so everything else will be doubled. So this guy, the asymptote is going to occur at pi. So it should look something like this. I'm starting at 3. That's kind of my center axis. I might draw that across. It's not an asymptote, I'll just draw a dotted line to indicate it. And then it should reach up to about there. Okay. So you can see I've got this shape here, and that's the part that's repeating.